MSX. MSX is a standardized home computer architecture announced by Microsoft and ASCII Corporation on June 16, 1983. It was initially conceived by Microsoft as a product for the Eastern sector and jointly marketed by Kazuhiko Nishi, then vice president at Microsoft and director at ASCII Corporation. Microsoft and Nishi conceived the project as an attempt to create unified standards among various home computing system manufacturers of the period, in the same fashion as the VHS standard for home videotape machines. MSX systems were popular in Japan and several other countries. Sony was the primary manufacturer of MSX systems at the time of release, and throughout most of the product's lifespan, producing more units than any other manufacturer. Eventually 5 million MSX-based units were sold in Japan alone. Despite Microsoft's involvement, few MSX-based machines were released in the United States. The very first commercial MSX to the public was a Mitsubishi ML-8000, released in October 21, 1983, and thus marks the release date. The meaning of the acronym MSX remains a matter of debate. In 2001, Kazuhiko Nishi recalled that many assumed that it was derived from Microsoft Extended, referring to the built-in Microsoft Extended Basic MSX BASIC. Others believed that it stood for Matsushita-Sony. Nishi said that the team's original definition was machines with software eXchangeability, although in 1985 he said it was named after the MX missile. According to his book in 2020, he considered the name of the new standard should consist of 3 letters like VHS. He felt MSX was fit because it means the next of Microsoft, and it also contains first letters of Matsushita, Panasonic, and Sony. Before the success of Nintendo's family computer, MSX was the platform for which major Japanese game studios such as Konami and Hudson Soft produced video games. The Metal Gear series, for example, was first written for MSX hardware. History. In the early 1980s, most home computers manufactured in Japan, such as the NEC PC 6001 and PC 8000 series, Fujitsu's FM7 and FM8, and Hitachi's Basic Master featured a variant of the Microsoft BASIC interpreter integrated into their onboard ROM. The hardware design of these computers and the various dialects of their BASICs were incompatible. Other Japanese consumer electronics firms such as Panasonic, Canon, Casio, Yamaha, Pioneer, and Sanyo were searching for ways to enter the new home computer market. Major Japanese electronics companies entered the computer market in the 1960s, and Panasonic Matsushita Electric Industrial was also developing mainframe computers. However, during the Japanese economy faced a recession after the 1964 Summer Olympics, Panasonic decided to exit the computer business and focused on home appliances. The decision brought a huge success, and Panasonic grew to become one of the largest electronics companies. In the late 1970s, the company intended to open new business other than home appliances. Also, the microcomputer revolution let Panasonic interest in its potential. One of Panasonic's distributors, Yamagata National, told Panasonic's president, Toshihiko Yamashita, that recently NEC personal computers sell well in Yamagata too, and our dealers also request merchandise. However, we must purchase not only personal computers, but also home appliances from NEC. I think Matsushita also need develop personal computers. Yamashita ordered the vice president, Shunkichi Kisaka, to develop a personal computer, and Kisaka called on Kazuyasu Mita of Matsushita R&D Center. Mita requested Nishi to cooperate on the development. They were already close each other. When they met at a seminar held by NEC, they noticed both were from Kobe and had graduated the same university. They often talked to each other about home computers. At the same time, Spectra Video contacted Microsoft in order to obtain a software for their new home computer. Nishi went to Hong Kong to meet with Spectra Video and suggested some improvements to its prototype. Spectra Video's president, Harry Fox, was willing to accept Nishi's proposals. Nishi conceived to create a unified standard based on its machine, and Mida agreed with his idea. Nishi wanted to involve Panasonic and Sony in the development of home computers. They were competing for videotape formats, but Nobuyuki Idai of Sony accepted his proposal. Idai thought Sony should cooperate with Panasonic on its development because the SMC-70, Sony's first personal computer, faced difficulty in the market when Sony started the computer business. Ida also wanted to invite NEC. Nishi proposed MSX as an attempt to create a single industry standard for home computers. Inspired by the success of VHS as a standard for video cassette recorders, many Japanese electronic manufacturers along with Gold Star, Philips and Spectra Video built and promoted MSX computers. Any piece of hardware or software with the MSX logo on it was compatible with MSX products of other manufacturers. In particular, the expansion cartridge form and function were part of the standard. Any MSX expansion or game cartridge would work in any MSX computer. Nishi's standard was built around the Spectra Video SV328 computer. The standard consisted primarily of several off-the-shelf parts. The main CPU was a 358 MHz Zilog Zyti, the Texas Instruments TMS-9918 graphics chip with 16 KB of dedicated VRAM. The sound and partial I/O support was provided by the AY3 8910 chip manufactured by General Instrument GI, and an Intel 8255 programmable peripheral interface chip was used for the parallel I/O such as the keyboard. This was a choice of components that was shared by many other home computers and games consoles of the period, such as the ColecoVision and Sega SG-1000 video game systems. To reduce overall system cost, many MSX models used a custom IC known as MSX Engine, which integrated Glue Logic 8255 PPI, YM2149 compatible sound chip, and more, sometimes even the Zyti CPU. However, almost all MSX systems used a professional keyboard instead of a chiclet keyboard, driving the price up compared to the original SV328. Consequently, these components alongside Microsoft's MSX BASIC made the MSX a competitive, though somewhat expensive, home computer package. Debut. On 27 June 1983, the MSX was formally announced during a press conference, and a slew of big Japanese firms declared their plans to introduce machines. The Japanese companies avoided the intensely competitive U.S. home computer market, which was in the throes of a Commodore-led price war. Only Spectra Video and Yamaha briefly marketed MSX machines in the U.S. Spectra Video's MSX enjoyed very little success, and Yamaha's CX-5M model, built to interface with various types of MIDI equipment, was billed more as a digital music tool than a standard personal computer. Evolution. MSX spawned 4 generations. The first 3, MSX 1983, MSX2 1985, and MSX2 Plus 1988, were all 8-bit computers based on the Zyti microprocessor. The MSX2 Plus was exclusively released in Japan. A new MSX3 was originally scheduled to be released in 1990, but delays in the development of its Yamaha-designed VDP caused it to miss its time-to-market deadline. In its place, the MSX Turbo R was released, which used the new custom 16-bit RAID 100 microprocessor developed by ASCII Corporation intended for the MSX3, but features such as DMA and 24-bit addressing were disabled. Like the MSX2 Plus, the MSX Turbo R was exclusively released in Japan. By the time the MSX Turbo R standard was announced in 1990, only Panasonic was manufacturing MSX computers. Its initial model FS Aeon ST met with moderate success, but the upgraded model FS Aeon GT introduced in 1991 sold poorly due to its high retail cost of 99,800 yen. Production of the Turbo R ended in 1993 when Panasonic decided to focus on the release of 3DO. The VDP was eventually delivered in 1992, 2 years after its planned deadline, by which time the market had moved on. In an attempt to reduce its financial loss, Yamaha stripped nearly all V9958 compatibility and marketed the resulting V9990 EVDP Roman III as a video chipset for PC VGA graphic cards with moderate success. Impact. In Japan, South Korea, Argentina, and Brazil, the MSX was the preeminent home computer system of the 1980s. It was also fairly popular in continental Europe, especially in the Netherlands and Spain. Classrooms full of networked Yamaha MSX computers were used for teaching informatics in schools in some Arab countries, the Soviet Union, and Cuba, where they were widely used in public schools, which allowed the Cuban government to educate students in computer subjects. In total, 9 million MSX computers were sold in Japan, making it relatively popular. However, the MSX did not become the worldwide standard envisioned because of limited adoption in other markets. Before the MSX lack of success in these markets became apparent, U.S. manufacturer Commodore Business Machines overhauled its product line in the early 1980s and introduced models such as the Plus/4 and Commodore 16 that were intended to better compete with the features of MSX computers. In comparison with rival 8-bit computers, the Commodore 64 sold 22-30 million units worldwide by 1985 and continued being sold for another decade. The Apple Roman II sold 6 million units, the ZX Spectrum over 5 million units, the Atari 8-bit sold at least 4 million units, the Amstrad CPC sold 3 million units, and the Tandy TRS-80 Model 1 sold 250,000 units. A Sony MSX2 machine was launched into space to the Russian Mir space station. Similar systems. The system MSX most closely resembled was the SpectraVideo SV328 home computer. SpectraVideo even claimed to be MSX compatible in advertisements before the actual launch of MSX systems, but it was in fact not completely compatible with it. This led to a new and short-lived kind of software cracking, converting. Since the MSX games were unplayable on the SV328 computer, SV328 crackers developed a method of modifying the MSX games to make them work on the SV328. In most cases, this included downloading the MSX BIOS to the SV328 from tape or floppy disk. SpectraVideo later launched the SVI 728, which completely adhered to the MSX standard. The Sega SG-1000, the Mimotich MTX, and the ColecoVision all have many similarities with the MS Zone standard, but none are really compatible with it. Porting games between those systems is somewhat easy. It was also very common to port games from the ZX Spectrum to the MSX, since both have the same CPU. The Spectrum 128 had the same sound chip. Localization. By default, MSX machines have a hard-coded character set and keyboard scan code handling algorithm. While MSX has full application software compatibility at the firmware BIOS level, due to minor hardware differences, replacement of the BIOS with another from different PC may render incorrect scan code translations and thus incorrect behavior of the keyboard subsystem for the application software. In 2011, AG Labs introduced Language Pack firmware, aiming to make each model support several localizations. By default installed into G-Rate-Bit instead of the kanji ROM, it allows changing the character set and keyboard layout of the machine at startup. This allowed changing between Japanese, Russian, international, and Portuguese locales, and the ability to change locales during machine operation using newly introduced basic command lang. Selected locale setting is stored into the unused RTC and VRAM memory space. Games. Several popular video game franchises were established on the MSX. Antarctic Adventure and Penguin Adventure. Aleste and Zanak, the latter developed and released alongside the original FDS version. Bomberman. Egerland. Metal Gear. Parodius. Yes. Puyo Puyo. Others received various installments on the MSX, including several titles unique to the system or largely reworked versions of games on other formats. Castlevania as Vampire Killer. Contra. Dragon Quest. Dragon Slayer. Final Fantasy. Gradius Nemesis. R-Type. Wizardry. Zack. Xevious Fargrout Saga. Wise. Manufacturers. MSX. Spectra Video, Philips, Allemaya, Sony, Sanyo, Mitsubishi, Toshiba, Hitachi, National/Panasonic, Canon, Casio, Pioneer, Fujitsu, General, Yamaha, JVC, Yashica, Kyocera, Gold Star, Samsung/Fenner, Daewoo/Yino, Gradient, Sharp/Ecom, Talent, MSX2, Philips, Sony, Sanyo, Mitsubishi, Victor aka JVC, Toshiba, National/Panasonic, Canon, Yamaha, AX/Seal *, DDX *, Daewoo/Yino, and TT. Talent, MSX2 Plus, Sony, Sanyo, Panasonic, /Seal *, DDX *, MSX Turbo R, Panasonic. Do-it-yourself MSX. AG Labs Note *, clones or unlicensed equipment. Legacy. 2001 Revival. In 2001, Kazuhiko Nishi initiated a MSX revival around an official MSX emulator called MSX Flyer. This is the only official MSX emulator, as all MSX copyrights are maintained by the MSX Association. In 2004, a Dutch company BASIC announced they had become the representatives of MSX Association in Europe. On October 17, 2006, BASIC launched Woom.net, a website selling MSX games in English and other languages, with a selection of 14 games. In Japan, game sales began earlier through Project Egg. Woom.net was the English counterpart of this. The one-chip MSX is similar in concept to the C1, a Commodore 64 clone also built on the basis of a single FPGA chip. The new MSX system is housed in a box made out of transparent blue plastic and can be used with a standard monitor or TV and a PC keyboard. It has 2 MSX cartridge slots and supports the audio extensions MSX Music and SCC+. A SD/MMC flashcard can be used as an external storage medium, emulating a disk drive, and can be used to boot MSX DOS. Due to its VHDL programmable hardware, it is possible to give the device new hardware extensions simply by running a reconfiguration program under MSX-DOS. The one-chip MSX also has two USB connectors that can be used after adding some supporting VHDL code. On June 7, 2008, the MSX Resource Center Foundation reported that the MSX trademark had moved from MSX Association to the MSX Licensing Corporation, referring to a Benelux trademark register page of MSX, which names the MSX Licensing Corporation as entitled entity till 28/10/2013. At that time, the website of the MSX Licensing Corporation that they linked to as source had a text saying, "We are planning to revitalize MSX, the innovative computer platform," on it. However, the website was later changed to contain only the logo of ITNI and Partners, and a link to ITNI and Partners' English and Japanese websites, and has no mention of the MSX Licensing Corporation at all. On June 26, 2008, BASIC reported on their website's front page that they are no longer the representative of MSX Association, due to being unable to achieve their goals of bringing about the commercial MSX revival beyond the Japanese borders, and the transfer of the MSX trademark from MSX Association to MSX Licensing Corporation, and no outlook on any progress in the Western one-chip MSX project anytime soon. As a result of this, WOM.net is taken offline as well, with its website redirecting to the BASIC's website, until a solution free of MSX Association's contributions has been completed. According to their post, they will cooperate with D4 Enterprise and the MSX Licensing Corporation in one or more retro gaming-related projects. On July 4, 2008, MSX Association's European Contact website, which states to be the only official contact place for MSX Association in Europe, reports that the MSX trademark and copyright has been under the MSX Licensing Corporation holding ever since 1983. It explains that MSX Association, chaired by Dr. Kazuhiko Nishi, is the operational division of MSX Licensing Corporation, which manages the trademarks, logo, and copyrights for MSX. According to the same article, D4 Enterprise refused to pay royalties to MSX Association for the use of ASCII artists' factories' work in one-chip MSX and the software licenses in Project Egg. The article mentions as well the ASCII MSX System 3, on which the one-chip MSX, also known as one-chip MSX or OCM, is based. On July 5, 2008, the MSX Association's Europe website posted an announcement reporting that D4 Enterprise was selling the one-chip MSX illegally. In the same post it is stated that BASIC no longer is their representative in Europe due to BASIC cutting off their relationship. 2011 revival. In 2011, AG Labs announced the launch of a MSX kit called G-Rate-BIT, the do-it-yourself computer for learning purposes, which was licensed by the MSX Licensing Corporation. Kit is priced at $499 and includes all necessary components to assemble a working MSX2-compatible computer, except for an ATX chassis, power supply, floppy drive, hard disk, PS/2 keyboard, and monitor. It also comes with assembly and operational manuals and a supplement compiled from vendor and community support from the G-Rate-BIT engineering community. 2014 revival. Some of the Korean forum members who made Zemix Neo created a new version of MSX called Mini IQ3000 QT, which has similar features to the IQ2000 MSX2. Made in Korea. Daewoo Electronics. It is based on one-chip MSX but has some special features like Scanline Generator and multi-language support. The Scanline Generator generates scan lines to show the MSX screen with better quality. It supports two languages at the same time. Normally, it shows Korean font and working as Korean version of MSX, but when pressing the Del key while booting, it changes to Japanese mode. Even though the default mode is Korean, the default font allocation table is Japanese, as it shows Japanese characters when executing Japanese version software. 2019 revival. In 2019, a group of fans developed the so-called MSX Mini Replica. It is a 1:2 scale reproduction of the Philips VG8020 computer compatible with the software of the MSX, MSX2, MSX2 Plus, and Turbo R generations. It incorporates two USB ports, an HDMI video output, and internally uses the same hardware as the C64 Mini, connecting an additional peripheral called MSX Player, can run original games on ROM cartridge. 2020 revival. The MSX VR is a computer released in 2020 and compatible with the MSX family of computers. Like the latest Msx game consoles, it is also based on a Raspberry Pi card with additional circuitry to connect the original MSX peripherals. System specifications. Peripherals. Keyboard. The keyboard is a functionally separate unit which could be connected by non-multiplexed and multiplexed interfaces. Multiplexed keyboard units feature additional data direction line, allowing sending scan line number to the keyboard using same data lines used for return scan code, decreasing overall number of wires between keyboard and machine. Non-multiplexed interfaces usually used for internal keyboards and some external keyboards, like Panasonic CF3300. Multiplexed interface is used for external keyboards, e.g. in Yamaha YIS805 model. The keyboard is organized as a matrix with maximum 11 input lines and 8 output lines, accounting for maximum 88 keys, including all control, numerical, and alphanumerical keys. Each scan line is regularly queried to identify the state of the keys on the line. Query speed is identified by the system interrupt frequency. Such organization allows system to sense state of each key, not exhibiting notorious problem with 8042 microcontroller-based keyboards when pressing several keys simultaneously. Usually more than 3 generates wrong input characters or renders inability to sense the press of more keys. Due to the keyboard scan being controlled by the system interrupts, one of the troubleshooting hints when an MSX machine does not display any image assuming power is present is to press the caps key to see if the respective LED toggles. If it does not toggle, the system is likely suffering a more serious problem than just lack of image on the screen, i.e., the problem with video cable or video display interface in overall. In 2009, Kamil Karimov designed the adapter board to connect PS/2 keyboard to the multiplexed MSX keyboard interface. The firmware embedded into its tiny chip was tailored for DWC-PC machines. In 2011, AG Labs embedded a PS/2 keyboard controller unit based on microchip microcontroller into its G-Rate BIT do-it-yourself machine. Its firmware is developed to directly convert PS/2 scan codes to the MSX keyboard scan codes. Thus, it is fully transparent to the applications, allowing use of the controller unit with different MSX-compatible machines and for different localization setups. Cartridges. MSX standard requires at least one cartridge slot. Most MSX models have two. These slots are interchangeable, so in most cases it makes no difference which slot a cartridge is inserted. The physical connector is a 50-pin 2x25 contacts standard 254 mm 0.1-inch pitch edge connector. Using these cartridge slots, a wide variety of peripherals could be connected. Regular game cartridges are about the size of an audio cassette, so-called Konami size. Despite their higher cost, this was a popular format due to its reliability and ease of use. Around 1985, Hudson Soft released the credit card-sized B card, which was meant as a cheaper and more convenient alternative to ROM cartridges. But it was a commercial failure, and very few titles were released on the format. Source files for development of the MSX cartridges are available from AGE Labs for Eagle. Floppy disk drives. MSX systems generally did not have a built-in disk drive, so games were published mainly on cartridge and cassette tape. Sony created a battery-backed RAM cartridge, the HBI-55 data cartridge, for some computers in their Hitbit line of MSX systems that could be used to store programs or data as an alternative to cassette tapes. Floppy disk drives were available for MSX, however, in the form of a cartridge containing the disk interface electronics and a BIOS extension ROM, the floppy disk drive interface, connected to an external case with the drive. In South America, many of these systems used a 5.25 in 133 mm floppy disk drive, but in Europe 3.5 in 89 mm drives were more popular. In Japan, some MS Zone systems included a built-in 3.5 disk drive, like the Panasonic previously named Matsushita-CF3000. In Europe, a range of Philips MSX2 systems, NMS-8000, 230, 8000, 235, 8000, 245, 8000, 250 and above featured either 360 or 720 KB 3.5 floppy drives. In 1985, the MSX2 was released, and these systems often, but not always, included a built-in 3.5 disk drive too. Consequently, the popular media for games and other software shifted to floppy disks. The MSX-DOS disk operating system had internal software mechanisms much like CP/M, so CP/M software could be ported reasonably easily, but had a file system compatible with MS-DOS. Its user commands were also similar to early MS-DOS versions. In this way, Microsoft could promote MSX for home use while promoting MS-DOS-based personal computers in office environments. The MSX 3.5 floppy disks are directly compatible with MS-DOS, although some details like file undeletion and boot sector code were different. Like MS-DOS-1, MSX disks formatted under MSX-DOS-1 have no support for subdirectories. In September 2012, AGE Labs extended the standard by including support for 144 MB 3.5 format. The 144 MB diskette size goes in two configurations: standard 1 sector per cluster, 9 FAT sectors, and compatible 4 sectors per cluster, 3 FAT sectors. MSX Audio. Yamaha 8950, commercially released as Panasonic MSX Audio FSC Aeon 32 KB of sample RAM, 32 KB of audio ROM. Philips Music Module NMS 1205 32 KB of sample RAM, no MSX Audio BIOS. Toshiba MSX FM Synthesizer Unit HXM UNINI 100 no sample RAM, no MSX Audio BIOS. 9 channels FM or 6 channels FM plus 5 drums. YM 3526 compatible. Adcom Record and Play with hardware acceleration. Can be upgraded to 256 KB of sample RAM. MSX Music. Yamaha YM2413 Opal, also known as MSX Music standard name. Panasonic FM Pack, Zemina Music Box, Checkmark FM Stereo Pack, DDX FMX. Technobytes FM Sound Stereo contains the compatible A3567 chip, 9 channels FM or 6 channels FM plus 5 drums, 15 preset instruments, 1 custom, built-in on most MSX2 Plus and as standard on MSX Turbo R computers. Emulation. MSX computers are emulated on many platforms today. Early MSX emulators were often based on the code of the Pioneer FMSX, a portable MSX emulator by Marat Faisalin. Many emulators removed Faisalin's ZITI emulation code entirely in later versions to avoid legal problems, as at the time FMSX wasn't free software. Somewhat later FMSX source code became free for non-profit use, however a license was still required for commercial use. On December 31, 2013, the Windows version of FMSX 3.7 was released, free for anyone to use. The official MSX emulator MSX in Japanese is produced by the MSX Association, of which the inventor of the MSX standard, Kazuhiko Nishi, is the president. As of version 0.146, MES currently supports 90% of all MSX versions. Virtual Console. In February 2007, Nintendo of Japan announced that MSX games will be available for the Wii's Virtual Console emulator. It was confirmed that the games would cost 700 Wii points and will become available from the middle of 2007. It also became available for the Wii U on December 25, 2013. Ultimately, 13 games, mainly Konami titles, for the Wii plus 1 for the Wii U were released for the service in Japan only. List of MSX emulators.